Hi everyone, let's get started because it's time. My name is Alexey Savatyev. I'm a program manager for Azure Cosmos DB. And this is my colleague Govind. Govind?
Yes, my name is Govind Kanchi. We work together on the Cosmos DB team. And since we have such a big crowd, we wanted to ensure that all of you guys get all your questions answered today about your Mongo API and Cassandra API world. So thank you very much for coming in.
Feel free to interrupt us.
Yes.
If you think that it warrants a question on whatever we are talking about or demoing. Okay.
Yep.
So we'll do a presentation and a series of demos for both MongoDB API and Cassandra API. So let me start first. For those of you uninitiated, I'm going to give a brief overview of what Cosmos DB really is, and then we'll talk about specific APIs that we have, NoSQL APIs, and the migration options for NoSQL databases. Azure Cosmos DB is a globally distributed and massively scalable database as a service from Microsoft, and its primary capability is being multimodal. It's built on top of Azure infrastructure. We are Ring 0 Azure service, meaning that we are present in 50 plus regions that Azure has. And whenever a new region gets introduced, we are going to be there by default. On top of that Azure infrastructure, we've built a resource governance stack that uses hardware and software to power this globally distributed, low latency database as a service. And the critical capabilities of that stack is turnkey global distribution, meaning that you can replicate your data to all those 50 plus regions and scale them back whenever you don't need them anymore. We provide elastic scale out of storage and throughput that is independent of each other, which is a very cool capability in contrast to the distributed databases that do this on the top of VMs. We don't. And we provide guaranteed low latency, single digit, in fact, millisecond low latency for reads and writes. That's for 1 kilobyte documents from a single partition. And those are money-back guarantees. We also provide 5 well-defined consistency models. That's 3 more than typical. Typically, from distributed databases, you get strong and eventual, and we provide 3 more. We'll briefly talk about them. And we also provide comprehensive SLAs on throughput, latency, availability, and consistency. We also developed different data models on top of that infrastructure, on top of these key capabilities. And it's truly a multimodal database because if you think about it, the data models that we provide, key value pair, for example, and document data model on the other side of the spectrum are completely different. Yet they do map to one standard representation that we call Atom Record Sequence, ARS, behind the scenes. So key value pair data model is exposed through table API, and you can think of it as a new version or more powerful premium version of Azure Table Storage. We also have column family data model that is exposed through Cassandra API, and Govind is going to talk to you in detail about that. Document data model is represented by SQL API, which used to be called Document DB API, and the product was called Document DB before, and you might know this product by that name. We actually renamed it and rebranded it to Cosmos DB exactly a year ago. During last build, actually it was slightly more than a year ago, April 2017. And another API that also represents document data model is MongoDB API. I'm going to talk about that in detail as well. And graph data model is exposed through Gremlin API. That's Apache Tinkerpop implementation. Very similar to Neo4j, but has much simpler query language to use. So I'm going to pass the word to Govind now, who's going to talk to you about the SLAs.
Sure. So since everybody's here, How many people use Cassandra today? Okay. How many people use Mongo API? Okay, so we're talking to people who know their stuff, so we cannot bluff more.
Okay.
Right? So the key part here is what we want you to take back as why are we doing this and how we are doing this. The time limit is a little short, but we can get into detail as much as whenever we get outside the room itself. So if you are managing Cassandra, how large is your Cassandra cluster? Anyone? 100 nodes? 50 nodes? 20, about 50 nodes, yeah? So the key part here is when you manage large deployed systems, you are worried about providing certain set of characteristics. One is availability, one is capacity for throughput as well as for the performance. And then you are basically managing and monitoring a lot of these systems, right? So what we do is we basically put a skin in the game. We basically go ahead and provide SLA-backed guarantees for performance, for the latency. For when we say performance for the latency, so we, as he mentioned earlier, so for both for reads and writes, for 1 KB of data, we provide you guarantees at 99th percentile. So when we write the data, we ensure the data is quorum committed and indexed all the time. All the data is indexed. And on top of that, we provide you the guarantee of the performance. We also provide the read guarantees, and these are across all the APIs. For 1 KB of data, again, single digit at P99th percentile. You don't have to do anything specific for doing any of these things, right? And this is all financially backed. The second important thing here that we provide is availability. As you might know that if you're coming in from normal relational databases or even from the regular NoSQL databases, managing availability, monitoring it is a pain. We make it very easy. We basically provide within a region 4 nines and across the regions 5 nines for reads. And as if you have attended the keynote, you might have seen that we just introduced the multi-master write. So you can expect, as we harden that feature, to integrate SLAs around that too. So you can get far more higher SLAs for writes too. Okay. And we again, our SDKs for our native APIs are built in such a way that auto homing. What that simply means is if one region goes down, automatically your client applications can move over to the other region. You don't have to do any changes at any layer at any point of time. Okay. Apart from these two, we also provide guarantees for the throughput. So what does that mean? So when you come to Cosmos DB as overall, you basically request for how many operations at per second level that you want. Okay. Now if you take back this experience of yours and move to IaaS-based systems, you would see immediately that you need to do a lot of planning. Right? In Cosmos DB, we try to make it very easy. You just need to tell us number of operations. What are those operations? Read, writes, updates, deletes, and queries, of course. And what we do is we have, as you mentioned, that we have a resource governance system. What that implies is for every operation, we take X amount of resources, and we tell you every time about them. So what that makes is the capacity planning is made very easy. You exactly know what you need. Of course, we also guarantee that throughput. What that simply means is since we are cloud-based, it doesn't mean that we basically share everything with everybody else. Whatever you provision is provisioned for you only, and that is guaranteed throughput. So there is no neighbor interference or anything like that. Okay, so that's the key perspective, and we guarantee again that by finance. So you can basically come back to us and saying, I asked for this much throughput and I'm getting X amount. What is the reason? And if you see that anytime it goes up or down, you can ask us those questions. Okay. Then we also provide ability for changing the throughput. And this throughput you can change without adding machines, without adding anything. If you're working with Cassandra or Mongo, if you want more throughput, you can of course add a machine. but you need to wait for the machine to be added up, tokens to be present, then the data to be present, and then basically that node is up, right? You don't need to do all of those things. You just use the code, the SDK, or the portal, and you can increase the throughput or decrease the throughput instantaneously. Unlike some other hosted mechanisms, we don't put any limits on any of that. Okay? Why is this important? Because then you don't have to worry about managing this throughput by hand altogether. Okay? Then we also provide you consistencies, as he mentioned. We provide if there is if you had attended maybe Andrew's session, I think you would have seen that we do talk about the consistencies a little bit more in detail. But in consistencies, normally, as you might have heard, there is strong or eventual, but we also provide a spectrum across them. So majority of the customers will either choose strong or eventual, but then there are customers who require more choice. So in eventual side, we provide consistent prefix, which is nothing but an order in the data, in the eventuality. Session is client controls consistency, where client basically says, I have seen this or I have written this, now give me the next set of items. And then on strong side, we have the bounded staleness and the strong. Bounded staleness is basically saying if the data is distributed across X regions, they all should be within sync within X amount of minutes or X amount of time or Y amount of operations. Okay? Now, one very important concept that you need to get away from the consistency, although the title is eventual or consistent prefix, it doesn't mean the data will flow after X number of hours or days or something like that. Data flows immediately the moment data is committed in one data center. We don't buffer or anything, we push the data immediately. So the only limitation is the speed of light to be pushed across. And we provide a matrix for you to measure that. Okay? So this is another important piece. And we guarantee this again, it is a financially backed guarantee. Right? You can change the consistency for the read operations from the strong to not so strong. While writing, as we mentioned, we always majority quorum commit and push the data. So you don't choose any consistency while writing. If you're using Mongo, if you're using Cassandra, you can say, okay, I want to write concerns. You can change it to just one, or you can say basically in Cassandra, you can go ahead and say, I want to write only to one node. In our case, we always take care that when you send us a write, it is always quorum committed. And then on top of that, we give performance guarantee. Right? Then finally, we on top of, so these are the 4 things that we provide you all the financial guarantees on. And then what we do is we also encrypt the data in motion and at rest, and make sure that you get automatic backups. We provide 2 free backups today. We are planning to improve that, and very soon you should see some more announcements on that front. But if you need more than 2 free backups, please contact us. Okay? So that's, I think, in a very short, what we provide out of the box. Because if you are managing large systems, you're worried about availability, you're worried about backups, you're worried about performance. We try to take care of all these issues that you don't have to worry about those things. Okay.
Thank you, Govind.
Yeah.
So the next one is actually yours as well.
Oh, okay, great. So, so let me just cover this part also, right? Why Cassandra? So how Cassandra and why Cassandra? Very simply, why Cassandra is that, so what do you do with today with Cassandra API, Cassandra deployments? Where is your pain point, right? And this is based on the customers like you whom we have talked over the years. And they basically came back when we introduced the Cosmos DB, and they basically said that if we get the similar environment where we don't have to manage a Cassandra cluster or multiple Cassandra clusters, that would be great. And what are the pain points? Pain points are basically managing the OS, managing the JVM, managing the Cassandra YAML settings, and understanding the impact of all of those things. Managing the compaction, managing the read repairs. Right? These are the overheads, or sometimes in the worst cases, Bloom filter settings and all other kind of things. So there are too many things that a Cassandra deployment requires from the folks who have deployed it. So what we try to do is basically we take away all that pain. You don't have to do anything. So what do we do is we basically provide a CQL level compat. So your applications can work as it is, and you don't have to do all the overhead of managing those things. So that's the basic thing that we are basically coming out with. Okay.
All right. And in terms of MongoDB, very similar benefits that you get from Cosmos DB. On MongoDB side, you might be dealing with replica set management, sharded cluster management, config servers, MongoS routers, and so on. So all of these operations are taken care by Cosmos DB. The replica set management is essentially internal to all Cosmos DB operations, all APIs, because the data gets replicated 4x, not 3x, 4x in all APIs by default in a single region. The partition management is also built in, again, in all APIs, so MongoDB API simply benefits from that. And there's no need to take care of chunk migration, so we actually take care of that as well. So all of the tools that you would typically use as a DBA on MongoDB side, they're actually compacted in a form of widgets in the portal, essentially. So you would need to monitor just a few widgets on the portal, and we'll show you how they look like. So in terms of capabilities that we cover on MongoDB API side, the first and foremost, we provide MongoDB compatibility on the level of the wire protocol. So we simply took MongoDB wire protocol and provided the implementation for it in Cosmos DB. There's not a single line of MongoDB running in Cosmos DB. It's a very important distinction. It's not a hosted MongoDB service. Okay, it's a Cosmos DB service, fully managed, that provides you compatibility with MongoDB API. It's compatible on the level of the data types, the operations, the commands, everything that you need to essentially put your data into Cosmos DB and get your data from Cosmos DB. Not necessarily manage the cluster. So we don't, for example, support sharding commands, or replica set configuration commands, because those are taken care of automatically. But other operations that are essential to getting the data, analyzing the data, saving the data, updating the data, they're all there. So what that means in practical terms is that you can use existing MongoDB applications with Cosmos DB in many cases, in majority of cases in fact, just by changing the connection string. And I'll show you how that works. You can also view and manage your data using familiar tools that you have used on MongoDB side. And some of these tools have no knowledge of Cosmos DB whatsoever, yet they work with Cosmos DB when connected through MongoDB API. And what that means is that they simply use MongoDB connection string to the same exact account that was created in Cosmos DB, for which you could use Cosmos DB compliant tools as well. Question?
Yeah. First, one question: do you support the aggregation API in Mongo as well? And the second is, do you support the latest version of MongoDB? The API was changed dramatically since 2.0 and 3.6. There were massive changes. Do you support them as well?
So first question was whether we support aggregation pipeline. We do. Yes, we do. It is not fully supported. Not every single construct within aggregation pipeline is supported. We actually have a list of every construct that is supported, and that relates to aggregation pipeline and other MongoDB commands on our website. It's public list. Second question, whether we support the latest version of MongoDB or not. We do not. However, it doesn't mean that we actually don't support the applications that were written for the latest version. Even MongoDB applications, if you ask MongoDB developers, they won't be able to tell you which version they support, because many features in MongoDB versions, they migrate from one version to another. Some of them deprecate, some of them drop, some of them are more popular, some of them are less popular, right? Majority of MongoDB developers do not use even half of the features of MongoDB. Whatever database version they use currently. So I'll tell you that we support majority of the functionality of MongoDB 3.2. We support some of the functionality of MongoDB 3.4. We support some of the functionality of MongoDB 3.6 as well. And there are some features in Cosmos DB that don't come from MongoDB API support necessarily, but come from the underlying functionality of Cosmos DB that are way ahead of current MongoDB version.
Yeah, and to add to that, we don't force you to use one version versus another. So our version, you basically opt in to use a particular feature. So whenever we release new functionality, the older functionality will keep working because we are working at the protocol level. So you choose in that I'm going to talk now, okay, the aggregation feature, it's an opt-in feature. Or some other features that, or big decimal that we added, right? That was an opt-in feature.
Decimal 128,
yeah,
as
decimal,
they call it.
So all those features are basically present, and we are our goal is as we go along, we have paying customers today, a very big chunk of the our Cosmos DB platform on the MongoDB API. And as if the customers give us feedback saying these are the 1, 2, 3, 4, 5 features that we need, and we definitely we basically prioritize that based on the customer's feedback. So let us know which features are more important and how important they are. We can definitely work with you. Okay.
Yep. So just to move along.
Yeah.
I'll show you one example right now. So this is the screenshot of the portal, and I'm going to show it to you how it looks like. But the key point here is that we provide you the MongoDB connection string that you can simply copy-paste to your application or to your tool that supports MongoDB. Put it there and simply press connect button, or launch the application. In many cases, it will start to work. In some cases, you actually need to migrate the data as well. In some cases, you will need to identify certain constructs that we do not support in your code, right? And we provide you workarounds for those, or you can find the workarounds yourself. But in majority of cases, it will just work. And I'll show you one particular example. So let me close this very quickly. Okay. I'm going to do duplicate of my screen here. Okay.
Oh.
This is Azure Portal. When you go to Azure Portal, you will see Azure Cosmos DB on the left-hand side. So if you click on it, there's a plus add button. If you click on that, it will allow you to create a new account where you can choose choose a unique name and the API. So if I choose MongoDB API here, and I choose existing resource group here, and the location, and press create button, it will essentially create a new MongoDB API account with all the credentials that I will need to connect through MongoDB tools. So while it's doing that, I'm going to choose one of my existing MongoDB API accounts, and if I go to the connection string page, that's where I see the MongoDB connection string here. I simply can copy it, okay, and take it to the tool or MongoDB shell, Mongo shell. But let me show you this on the example of the tool that I have, Studio 3T, very famous and very popular tool among MongoDB developers. Used to be called Mongo Chef, I believe, before. This is the same company that purchased RoboMongo as well, so they call it Robo 3T now. So anyway, that tool has no knowledge of Cosmos DB whatsoever. It wasn't created for Cosmos DB. We never worked with them, I promise you that. But it has this connectivity to MongoDB, and when I create a new connection, and I can call it simply Cosmos DB, they have this nifty feature called from URI. So I simply copy paste my connection string here that I've just copied from the portal, and if I click test connection, see, it works. So I can actually save it and connect to my Cosmos DB to wherever it is. Where did it go?
What was the name?
Cosmos DB2, I believe I called it.
You can search, no?
There's no search feature. Weird. Okay, let me do it again. Okay. From URI. And I save it. Did you save it this time? I don't see it. Oh, maybe I just ran out of the number of different connections that I can make. Okay, so I actually connected to this account before. Okay. So this is it, actually. So let me just use that. So this is my Cosmos DB account. It looks and feels exactly the same as if it was MongoDB account. So I can click on the collections, I can execute commands from here, and those could be sophisticated commands as well. So for example, I connected locally to my MongoDB database here. I can execute aggregation pipeline here against MongoDB or Cosmos DB. So if I copy this here and execute it, see, I get the results. This is aggregation pipeline running against my Cosmos DB account. Okay. Now, switching back to the presentation. Now, what is the typical MongoDB API workflow? So as I've shown you, you first have to create an account with Cosmos DB. That's one-time thing. You can use the CLI, or you can use the SDK for that as well, or you can manually create it on the portal. All you need to get from it is credentials, essentially, and then you populate the collections with the data. You can do it manually through portal. You can do it through Mongo import, Mongo restore, or any other tool that you like to use, and then you execute queries in your code or in your tools, or Mongo shell for that matter. Now, what are the migration options? You can use Mongo import and Mongo restore, as I mentioned. Those two tools do not have any knowledge of some Cosmos DB things like provision throughput. Remember, we charge for throughput and storage separately. That means that you might not have paid for a lot of throughput, and therefore you may run out of throughput per second that is provisioned when you launch these tools, because they have no knowledge of throughput. They try to pump the data as fast as possible, right? Because on MongoDB side, it's typically on-prem deployments where you have enough hardware to actually process any kind of data ingestion that is possible with the I/O and CPU and memory that is on the client side, right? In here, it's not the case. You might provision actually very little throughput because it costs money. Therefore, we suggest you to use two parameters that we actually list here: num insertion workers and batch size, where you can self-limit the ingestion rate, or you could always provision more throughput. But if you see errors such as request rate too large or HTTP 429, that will tell you that you don't have enough throughput provision for the ingestion rate that your client tools support. So that's why you need to use these two parameters. They are native MongoDB parameters, by the way, supported by these tools. Now, another option, which is much better option if you ask me, because it does have knowledge of Cosmos DB internals and provision throughput concept, is called Cosmos DB Bulk Executor tool. And it exists for MongoDB API as a separate tool. It exists in a form of a library as well that you can use in your code. It exists for other APIs as well. But it knows that there is provision throughput. It knows that it has to provide the ingestion rate that is lower than that provision throughput, so you won't run into issues like that with it. And you could also use Azure Data Factory version 2, because the first one did not support MongoDB API. It did support Cosmos DB, but not MongoDB API. Now they provided MongoDB API and Cosmos DB as well. And this is essentially just the list of things that you would probably need to do when you provide the migration in your custom code or through MongoDB tools. You essentially need to pre-create and scale your collections first, so you need to provide enough throughput for the migration to succeed within within a reasonable time frame. Then you have to calculate the approximate RU charge, which is request unit. Request unit is an equivalent of processing 1 kilobyte document with one partition. Essentially, all the resources that we use to process 1 kilobyte read from a single partition, it's a combination of I/O, memory, CPU that we utilize to process that. That's 1 RU. One write would be 5 RUs. It's actually writes, since they need to replicate the data. They are more expensive. So now that RU charge is separate for every query, right? It depends on the size of the document, depends on how many regions you want to write that document to, right? Therefore, execute your write command once, only once, and figure out the RU charge. There's a command that we use for that, get last execution, get last request statistics rather, and that charge is going to be used for calculating the num insertion workers and batch size parameters. We actually provide the formula for that on our website. And then you determine the latency from your machine to Cosmos DB, because that's also a factor. If you're located on the other side of the globe, you will add 200 milliseconds just for the speed of light. Therefore, you have to take that into account. And you remove all the temporary documents and calculate batch size and num insertion workers and run your Mongo import or Mongo restore. And this is just an example, the real world example of values that you calculate and in the formula that is used. Again, we have this on our website in the documentation that is specific to MongoDB API. And this is an example of Mongo import with all the parameters that you would specify in that case. The only thing that is omitted is the password, which is one of the components of the connection string that I've shown you. You can get it from the portal. All right, Govind, do you want to?
No, I think this is monitoring for you still, I guess.
All right, I can cover that. So metrics page,
Yeah.
let me show you that. This is
2 parts, yeah.
This is very interesting portion because you will probably use it quite a bit. Okay, so if we go to the portal again, there's a metrics tab here under monitoring section. And in the metrics, what you could see here is the overview of everything that I've got under this account. As you can see, I have 2 regions. It's West US and South India. I did have some requests coming in. Remember, I launched Studio 3T running against this account. So this is it. This is the last hour, essentially, aggregated over a 1-minute interval. And those requests were HTTP 200, so I got everything I wanted. As you can see, HTTP 429, which is request rate too large or throttling events, did not happen yet. So I don't see anything. Now I can watch this per database. If I switch to throughput tab, I can actually start watching this metrics per collection. So my test database is called test, and the collection that I've run it against, I believe it was orders. So you can see some aggregated metrics here, number of requests per 1 minute, request charge, that's the RUs that I was talking about. So essentially you could see I was charged only 6 RUs for that query. That's nothing. Oh, by the way, in terms of pricing, we charge it in 100 increments. I believe the lowest that we currently have is 400 RUs per second. That will cost you about $24 per month. That's the lowest charge. Now, we also have number of error requests here. Nothing here. And this is the provision throughput. My collection has 1,000 RUs per second setting. And as you can see, I barely reached anything, right? So You just have to watch this particular chart here more closely so that this light blue line never crosses the dark blue line, because that's when you will start not getting the data that you expect from Cosmos DB, and therefore you have to either self-throttle or provision more throughput. Okay, so I think enough about that. Let me switch back here.
Okay, great. Thank you very much, Alexei. So what I will do is try to find out now, or try to share what we are doing on the Cassandra API space. We are still in private preview, so some of the cool things that you see on the Mongo API, like monitoring and other pieces, we are still building it out. We are working with few set of customers who are paying customers at this point of time. We are interested in working with set of other customers. If you are waiting, so thanks for your patience. If you have some urgency, please reach out to us at Ask Cosmos DB API, and then we can help you onboard after understanding how you're using. As you saw today or 2 days back, we just announced multi-master capabilities. So we are planning to adopt that and harden that feature so that normal Cassandra users can use that capability out of the box, right? So what do we provide out of the box? So let's do one thing. I'll make it 6, right? Let me just walk you through the demo and then basically talk you through everything else. So what I'm going to do, I'm going to walk through a very similar experience. An idea here is hopefully you carry back is that it is very straightforward and simple to manage large amount of databases. That's the key part, without the overhead of managing those. So let us see, Cosmos DB, there is a Cosmos DB there, and it's very simple. It says C2 demo, and you choose the API. It takes some time, and you just go ahead and create it in a particular resource group. Once it gets created, what you will do is you will most probably end up in overview section of a particular account. So here what you can do, there are a few things, right? One is you can add a table, and add a table is basically in Cassandra is basically a key space, so KS1 and let's say T1, and let's just take it as it is. Now the key part here is whether it is Mongo, whether it is Cassandra, whether it is Azure Table or SQL API, one thing that you need to provide to us, only one, well actually 2 things, but one thing which is explicit is basically the throughput. What is the other thing? And I'll come to that in a bit. So the throughput is calculated based on how many operations you're going to do at a per second level. Okay. So as long as you can get that part, and we make it very easy to tell you all that pieces of information. In Mongo, as you saw, there was a command get, what was that?
Get last request statistics.
Get last request statistics. In Cassandra also something similar exists. And you can get that information for reads, writes, queries, and updates and deletes, pretty much everything. And then you basically estimate that and add it up here. Once you do that, of course, you can create, if you want anything more than 100,000 RUs, it is completely possible. We just don't allow it on the portal to protect customers, because whenever you provision, at that minute you start paying. It's a provision throughput model. So if you need something like millions of RUs, 10 million, 5 million, contact us, we can help you out. We already have customers who do that. Once you have it up and running, what can you do? Of course, you may or may not use this, right? I already have something which has got an existing amount of data. You can add data. We are trying to build this query builder. We are trying to make this as complete over the time. But most probably what will happen is you will do 2 things. One is you will either change the throughput. You can change this throughput through CLI or through code. Why would you change this throughput? Because you want more of the throughput or you want less of the throughput. And this is instantaneous. The other thing you might change, there is one more thing, right? We kept talking about this. If you're using Cassandra, and Cassandra does not support you have to create secondary indexes explicitly, right? Cosmos DB indexes all the data automatically. You do not need to create really secondary index tables. Okay. So what does that mean? That means that by default we index everything. So there is a bit of, if you want to change this, we document how to change this information. The idea there is you tell us which parts are excluded, or rather which attributes are excluded and which attributes are included. By default we include everything. Okay. So this is the only thing that you will change once the system is up and running, or basically just before the system gets up and running. Okay. There is then what would you do? You most probably would go to your SQL shell. Unlike the rich ecosystem of the Mongo world, Cassandra has a very dedicated few set of things, tools that would work. Right. One of them is SQL shell, and the way you can connect to that is basically pretty much take this whole execute whatever we have shared here. What does it have? It has two pieces of information. It has, just like Mongo, it has username, it has the port, it has where exactly this particular Cassandra's endpoint is present. And that's the key point, right? Once you have that piece of information, you can take this as it is and paste it, I think somewhere here, right? And you can use existing SQL shell of Apache Cassandra, and it is pretty much the same thing, and you can connect it. Okay, so you are now in the SQL shell. So let's see, use was it cdemo? Select star from, I forget the name. What was the name of the, D1 or T1? Yeah, D1. So those are the, of course you can do something more. You can then basically add the data also. The key point here is that your tools, your code which uses SQL as a protocol will work as it is. Now there might be questions, hey Govind, what happens to thrift? We don't support thrift today, but if there is enough input, we will definitely look at it. But as of now, if you have been following the Cassandra land, thrift has been deprecated for quite amount of time, right? So this is out of the box feature. So unlike if you have ever set up a Cassandra cluster, you did not have to set up machines, you did not have to set up JVM, nothing. You just come in here, provision the system, and start using it. Of course, you can do something more. You can use your, so this is just Node.js, which is you can take your existing piece of code and connect up. And only thing that you need to change, as Alexi was already saying, the connection information, which is username, password, and the contact point information, and that's all. Once you do that, you can go back here, and this is pretty much the same stuff. It should show an extra amount of data now, which we just put in, and that's basically it. So hopefully, although we have tried to make it very simple, but people who manage large Cassandra clusters see what we are trying to do is that we are trying to remove the management overhead of Cassandra clusters. We are trying to provide you the performance guarantee for read and write. We are trying to basically enable the global distribution without you managing all that stuff. And this is the key capability, which is based on the core Cosmos DB capability. So having said that, let me switch over to the Cosmos DB side, right? So what do we provide? So as you saw, we basically, just like Mongo API, on this side too, there is a SQL protocol, which is what we provide compat with. We also provide the compat with pretty much all the CRUD operations and the data types. We are building few features. One of them is basically the multi-master at this point of time. We will be adding the other features which customers request. So let me share something like materialized view. Apache Cassandra deprecated that feature, market deprecated last year or so, or maybe a year ago. We also, when we were working, there are so many features, right? So we were thinking of whether to support it or not, but then customers have existing code base, which uses create materialized view and use materialized view and so on and so forth. So we decided to support it. So it is definitely dependent on what you want to do. we also there's one more thing that I would like to show if I get if I can, that is, we also support automatic indexing, and you can use index operations directly on top of the Cosmos DB. We'll support all of those things. If I show you the just could you just go there and let me just show one. So can anybody tell me a command for C? I think, is it key space or describe? Great. So everybody is still awake. Describe. Is it key space or just C demo? So let's see if it shows up, right? Yes. So if you see at the bottom, right? So this is the usual stuff of the Cassandra which we provide, but then at the bottom we also provide the index information, which is automatically created for you, right? Of course, you don't have to manage all other things internally here, the read, repair, and everything. We do all of those things. Again, to re-emphasize, just the way Alexei mentioned, there is no Mongo code running on Cosmos DB. Similarly, there is no Cassandra code running on Cosmos DB. We provide the compact. And then idea here is that you don't have to spend time on read repairs, compaction, all other kind of things. Or basically managing the lags, managing the JVM. You should not be spending time on those things. And that's the goal. Okay, I will switch over. Thank you very much. So how do we, so then the question comes, when you're using Cassandra, what are the things that you can do, right, to move the data, to start using it? If it is a greenfield application, it's pretty straightforward. But majority of our customers are going to be the customers who already have data within existing Cassandra clusters. So there are various options, but two options which come out very strong. One is ADF v2. We are working with our ADF team out of China to basically help build us this capability. And we also have a tool which we announced a few days ago, bulk executor tool, which we will adopt for this particular for importing data into the Cassandra world. Okay, we can help customers offline one-on-one at this point of time to bulk load a lot of data. Okay, so that's first part, right? The other part is you do not have to worry. The goal is here is that your existing applications with existing SDKs just work out of the box. You do not have to worry about a lot of the things. Okay, then so just like the way we explained in the MongoDB API, you saw how to manage or monitor. You would just use the metrics which are on the portal or create alerts on the portal. And if you are interested, tomorrow you can come down. I will explain to you how Cosmos DB does for the SQL API, and pretty much the same concept will apply in the Cassandra API too, to create alerts and to monitor all those pieces. There are only two things that you need to manage within Cosmos DB world for pretty much all the APIs. One is throughput, the right throughput at a per second level, and second is the good partition key. Partition key, because we can store petabytes of data. As long as you have a good partition key, we can scale out and store all the data. Throughput, because throughput at a per second level defines how many operations, whether inserts, updates, you can do. So those are the two things. If you get right, you do not have to worry pretty much. And majority of the customers who start using us, they have great experience after the first workload, and then they basically move. They keep moving. Actually, the only thing is then supporting them as we go along, right? We just saw how to create all this stuff, right? It's pretty straightforward. You connect up, create an account, and create a key space and a table. We make it as simple as that, right? I did not show you the global distribution, but if you use Cosmos DB, it's pretty straightforward. You add another region. You do not have to worry about adding nodes, all those kind of things, right? We make that also pretty straightforward out of the box. Then usages, right? We looked at the usage for both the shell purposes or other places, is to get the information out of the connection string, just as the way Alexei described. For Mongo API, we have similar information exposed out, and you can get that and just substitute it, right? And our SQL shell compat is pretty much there. What does not work? I think the question would be, Govind, what will not work? Just like in Mongo API, you don't want to manage shards, right, in Mongo API. In Cosmos DB also, you don't want to use the node tool commands, because there is no node exposed to you to manage it. All the data plane operations you can definitely do. Everything else is basically not required to do. Okay, so that's the way to think of it. Okay. Of course, we are open to feedback, and you tell us, hey guys, we want to do X, Y, Z. Let us know, and we will be interested to, because we're still under development, active, and we keep improving it. So we will be open to improving it further ahead. As I mentioned, we generally have two kind of customers. One is completely greenfield customers, and we have seen mostly the IoT customers using time series, versus the customers who are storing a lot of data in a key value mechanism, or the customers who have existing large clusters and want to take advantage of managed hosting. So those are the two set of customers, and we are working with whole set of customers across retail, IoT, and pharmaceuticals. Also, we are interested in working with more customers, so reach out to us whenever you have chance. And folks who are waiting, we will have good news as we go ahead. We will start approving all the earlier requests as we go along. Okay. Now, what are the scenarios that we have seen? And based on that, this particular information is being shared, right? Majority of our customers use Cosmos DB. Cosmos DB core also is used heavily with Spark. What we have, as you already know, if you're using Cassandra, customers generally use some kind of ingestion, and Cassandra as a store, persistent store, and of course Spark on top of it. So we definitely support Spark on top of us, using both Cosmos DB as a native API as well as Cassandra API, right? The only thing that we have added is basically just like the way we added to the Mongo API, which is non-intrusive, is basically a way to get you the RUs. RUs, as we mentioned, is the way you provision the throughput at a per second level, right? It is completely non-intrusive, and we basically provide that information for you to manage, monitor, or scale up or down, right? We pretty much support all the drivers. If there are some drivers who take some unknown dependencies and you are working with them, please let us know. We'll be interested in working with them. We have customers who have pretty much work across Java, Python, and Go. So pretty much everything works, but if there are other things, please let us know. Scala does work because we have Spark customers. Okay.
And pretty much the same list applies to MongoDB API?
Yes.
Except for the first two that are Cassandra specific.
Yes.
All the standard and official and community MongoDB drivers will still work.
Yes. And there's one more thing Cassandra stress. If you ever use it, it works out of the box. So not all of the customers use, but some of the customers still use. So what is it that we have today and what we are planning? We are basically going to add monitoring. As you saw, there is rich monitoring today with the Mongo API. We are working on the Mongo API piece. Depending on the feedback for the shared throughput for the Cosmos DB, SQL API, and the Mongo API, we have to see how to incorporate that into the Cassandra API too over time. It is not yet done work. And then, of course, the multi-master was just announced again in private preview. So we have to adopt that also into the Cassandra API. So that's the kind of work, major work, which is remaining at this point of time that we are working, right? So at this point of time, we are open to customers to see what other inputs that you require from us to improve. So reach out to us. We can definitely help you out. If there are questions, you can send all the questions to Ask Cosmos DB Cassandra at Microsoft.com. Our basic, I think, people who use Cassandra, they can just use it as it is. The only two things that you need to get right. One is the throughput. Partition key in Cassandra is very easily managed because you have to define a partition key. And so that's not a new thing we have to tell customers. It's only the throughput part of it. Okay. So those two pieces are done. We can assure you that the Cassandra API, if you're using existing Cassandra cluster, Cassandra API will be a good choice to replace that. So with that, what I can do is I can just take a break and let you folks ask the questions and go ahead. Yeah. So there's one more important thing. Yeah. I guess, yeah, Mongo API.
Similar resources exist for MongoDB API. We actually structure our documentation and quick starts by API. Slightly different alias to ask the questions. You can always shoot your questions to Ask Cosmos DB actually in general, but for MongoDB API, here's the alias.
And yeah. Go ahead.
And we're always looking for new people to join our team. If you have passion around databases, if you have experience creating them or working with them at large scale, please send us your resume.
Join cosmosdb.com, right? Yeah. So
yeah,
so if you go to our Twitter alias, you will find us. So definitely we're looking for a whole set of good people, and just an extra pitch. If you are interested in working with good team across the world, let us know. So thank you very much for your time. We, I think, have finished a little earlier, so we are open to questions. Thank you. Yeah, thank you.
Thank you.